Welcome again, ladies and gents. Today the focus of our video is going to be about naming ionic compounds. So we have an idea of what an ion is. Now we're going to focus on how we name a compound that contains ions. The first thing we need to understand is what a binary compound is, because that word binary is going to come up a lot in this chapter. That prefix bi means two, so a binary compound is going to be a compound that contains two different elements. Those two elements can either be a metal and a nonmetal bonded together, or two nonmetals bonded together. So if you're looking at the periodic table, you can decide which one of these types of compounds you have by looking at the elements. In our first example, KCl, K comes from the metal side and Cl comes from the nonmetal side, so we're dealing with a compound that contains a metal and a nonmetal. If we look at our last example, the N and the O both come from the nonmetal side, so we have two nonmetals in that example. These are all binary compounds because they only contain two different elements. The first example has potassium and chlorine, the second one has calcium and bromine, and the last one has nitrogen and oxygen. So they're binary compounds because they contain two different elements. Now our focus for today for naming is going to be for ionic compounds. So if we think back to the first day of our notes, we're going to be dealing with compounds, that contain a metal and a nonmetal. So we're going to see one element from the left side and one element from the right side. Now, when we talk about ionic names, all of our compounds are going to have a first name and a last name. So some examples you can see down here are sodium chloride, potassium phosphate, and magnesium nitrate. The first name is always going to be from your metal. The second name is always going to be from your nonmetal, and that's true of any ionic compound. So just like you guys have a first name and a last name, all of our ionic compounds also have a first name and a last name. Now, not all ions are made the same. Our ions are broken into two groups. Our first group is called a type 1 binary ionic compound. In those type 1 binary ionic compounds, your metal will only make one type of ion. These are the guys that we've been working with the past couple of days. Those metals are going to be found in group 1, group 2, or group 3. So that would be things like lithium, magnesium, aluminum. Those are the guys that come from group 1, group 2, or group 3. In their type 1 binary ionic compound, they're typically going to be stuck to a metal from group 6A or 7A. A nonmetal from group 6A or 7A. So when we're naming these type 1 binary ionic compounds, how your name goes is your cation comes first and your anion comes second. So your metal is just going to be copied straight from the periodic table. Your nonmetal is going to change the ending to IDE. So what do we mean about that? If we look at the example here, NaCl, you can see that our cation, sodium, comes first. So we're just going to look at the name on the periodic table and write it down. Our anion comes from the chlorine atom, but we're going to change the last part. It's not going to be chlorine anymore. We're going to change the ending to IDE. So we're going to keep the chlor and add an IDE to the end. So our name is going to be sodium chloride. That's it. So if we look at these examples, all these things are type 1 metals. The metal will always come first in the name, and it will always come first in the compound. So Rb comes from group 1, K comes from group 1, and aluminum comes from group 3. That's how we know they're all type 1 binary ionic compounds. And they're all going to have a first name and a last name. So I like to put the lines so it reminds me that I have to give them a first name and a last name. The first name, we're just going to copy the name of the metal. So Rb is going to be rubidium. K is going to be potassium. And Al is going to be aluminum. The last name, we're going to change the element name to an IDE ending. So our oxygen is going to get changed to oxide. Our sulfur is going to get changed to sulfide. And you guessed it, our nitrogen is going to get changed to nitride. So that's it. For a type 1 binary ionic compound, your metal name is just going to get copied straight off the periodic table, and your nonmetal name is going to get changed to an IDE ending. That's it. Your type 2 binary ionic compounds are going to be named just a little bit different. And where the difference comes in is the metal. In a type 2 binary ionic compound, we're dealing with metals that can make more than one possible charge. Remember a few days ago when we were talking about ions and we skipped the transition metals? The reason we skip them is because your transition metals can make more than one type of charge. They can do funky things with their electrons when they lose them. They don't always lose the same number of electrons. So for example, sometimes copper is going to lose one electron to become a +1. Other times it's going to lose 2 electrons to become a +2. So all those transition metals, all those metals that sit in the middle of your periodic table, they can make more than one possible charge. So since they can make more than one charge, we have to name them just a little bit different. They're still going to follow the first name, last name format, but what we're going to do is we're going to put these parentheses in the middle of our first and last name. What that parentheses is going to do is it's going to give us the charge of our ion in Roman numerals in between the cation name and the anion name. So how you name the cation and the anion does not change. The metal name gets copied from the periodic table. The nonmetal name gets copied from the periodic table and then changed to IDE at the end. The difference lies in this parentheses. What we're going to do is we're going to put a Roman numeral that will tell us what charge the ion has. So let's look at a couple of examples. Copper we know can make a +2 ion. So if we look at these two formulas, they look pretty similar. We've got CuO versus Cu2O. What's the difference? How do we name them? Let's look at CuO first. When you're dealing with an ionic compound, they have positive and negative charges. We're going to learn that the total positive charge and the total negative charge has to equal 0. So when we're looking at trying to figure out what charge our metal ion has, the anion is going to help us. Because if we look at these ions, we've got one copper ion and we've got one oxide ion. So they have to equal a total of a charge of 0. We don't know what the charge is on a copper, so we can give it X. We do know the charge of an oxygen ion is a -2 from our periodic table because it's got 6 valence electrons, so it needs 2 more to get to 8, so it takes on a -2 charge. So if we want to know what the charge is on our copper, we just solve for X. So X minus 2 equals 0 tells us our copper ion has to have a charge of +2. So that means we're dealing with this +2 copper ion. So how do we name him? We still give him a first name and a last name. The first name is still going to be copper. Oop. Let me try writing that in a different spot because that is getting cut off by the screen. But the difference is we have to give the Roman numeral charge. Since we just solved for it as +2, the 2 goes in parentheses. So copper 2 is going to be the cation name, and the anion gets named the exact same way we did before. We changed the oxygen to an oxide. So how is CuO different from Cu2O? I don't know what I hit. Here, it's going to be a little bit different because this time we don't have one copper ion, we have 2 copper ions. So our algebra is going to be a little bit different because we don't have just one copper, we have 2. So we would have 2x this time, so we've got 2 of our copper ions, minus 2 equals 0. So we would have 2x equals 2. So x would equal a +1. So this time we're dealing with the copper with a +1 charge. So our name is still going to be copper, but this time we're going to put a 1 in Roman numerals in parentheses because we're dealing with the copper atom that has a +1 charge. So when you're naming your type 2 ions, you're going to have to do just a little bit of algebra, a little bit of math, to figure out whether you're dealing with something that has a +2 charge or something that has a +1 charge. And you use the negative ion to figure that out. So let's look at a couple of examples. So here, we know they're all type 2 binary ionic compounds because all of our metals in these examples come from the transition metal area. The iron is in the middle, the iron again is in the middle, and the copper is in the middle. So let's go ahead and let's do our simple algebra to figure out what Roman numeral we need to use in these names. So our first example, we're dealing with iron, and it is stuck to a nitrogen. So let's go ahead and let's do our algebra. So we know from the periodic table, we don't know what this guy is, so he's going to be our X. We know from the periodic table that our nitrogen is a -3 ion. So we would do X minus 3 equals 0. So simply here, X would equal a +3. So we can go ahead and follow our first name, last name format. Iron is going to be our first name, and we're going to go ahead and put a 3 in Roman numerals because our iron has a +3 charge. The N comes from nitrogen, so we're going to change the ending to IDE. So our name would be iron 3 nitride. If we look at the next example, we're dealing with iron again, but this time we're dealing with an oxygen that has a -2 charge. So we'd set up our algebra, X minus 2 equals 0. So we would have X equals a +2. So in this case, our first name would be iron, but a 2 would come after it because this time our iron only takes on a +2 charge. And the O would change from oxygen to oxide. Our last example, we've got 2 of these chlorine guys. We don't know what our copper is. We know that each chlorine is a -1, but we have 2 of them. So we would set up our algebra as X minus, we would do X minus 1, but we'd multiply that by 2 because we've got 2 of them in this case, equals 0. So we would have X minus 2 equals 0. So X equals a +2. So in this case, we would copy down the word copper as our first name. And since we have a +2 charge, that would be what goes in our parentheses. And the chlorine would get the IDE ending to become chloride. So that's the big difference between a type 2 naming. In a type 2 compound, you have to put the charge in parentheses in Roman numerals. So I'd like you to do and fill out on your Google form is I'd like you to try these 2 compounds. I will tell you one of them is type 1 and one of them is type 2. So go ahead and try and type in the names correctly on your Google form, and we'll start with these examples tomorrow in class. Remember, if you have any questions, you can always come in early or email them to me. Have a great night, guys.